All right, hello geometry guys. This is Mr. Heeren. We're talking about Unit 3, Part 1, classifying triangles. This whole unit is talking about triangles, and we're really getting into the finer details of what makes a triangle, what is so special about triangles, and most importantly, why triangles are the basis of every other shape. So now, we start off simple. We start off, can we classify a triangle? Well, we start off by this. We go by the name, we go by the sides, we go by the angles. So if you look, this angle is clearly bigger than 90 degrees. So anytime you have one angle bigger than 90 degrees, that's going to be called obtuse. All right, so that is going to be called obtuse. All right, all three sides are different, so that is going to be a scalene triangle. So what you would name this triangle would be a scalene obtuse triangle, or obtuse scalene, but I think scalene obtuse actually fits just a little bit better. So that would be a scalene obtuse triangle. So if you're looking at different kinds of triangles, you're trying to name them by angles. All right, so first one is going to be obtuse, which we just looked at, because you clearly have an angle bigger than 90 degrees. So you have one angle bigger than 90. All right, one angle greater than 90. So one angle bigger than 90 degrees, like that. So the second one, if you look, all three of these look equivalent. Okay, that's not a trick. That is exactly correct. All three of these are congruent. So you have three congruent angles. When you have that, we call that equiangular. That is an equal angular triangle. And you exactly have three congruent angles, and they all happen to add up to 60 degrees. Or not add up, but they all happen to be 60 degrees. This one, it has all acute angles, so that's what we call it. It's an acute triangle. So all we say is all angles are less than 90 degrees. All right, so you have all angles less than 90 degrees. The last one has got a right angle. All right, 90-degree angle, it has exactly one of those. So you have one 90-degree angle. One 90-degree angle is enough to tell me that it is a right triangle. And that is exactly what it means. It's got one 90-degree angle. That is how it determines it. So those are my four possibilities by angles. You also need to be able to do it by sides. Okay, one big key idea here. Triangle angle sum theorem. In any triangle, if it's truly a triangle, if I add up all of the angles in a triangle, it needs to be 180 degrees. That is significant because here's what's kind of fun. You can take any triangle, and if I was going to rip this apart and rearrange the angles, so if I tore this off and rearrange the angles, it would actually create a line. All right, it's kind of a cool thing. So every single triangle is going to be 180 degrees. All right, if it's not 180 degrees, it's not a triangle. So let's look at this thing. So the name is going to be obtuse. Now, all three of these are different lengths, so that's going to be scalene triangle. Classification of triangle, it's going to be obtuse. And x has got to equal, well, 100 plus 25 plus x has got to equal 180. So I'm going to subtract from 125. So x has got to be 55. So acute angles of a right triangle are complementary. Hopefully this kind of makes sense. All right, think about this. A triangle is 180 degrees. I've got a right triangle, which means one of the angles is 90. So if the sum total of the whole triangle is 180, I have the one right angle that is 90 degrees. That means how many do I have? How many degrees do I have left? I have 90 degrees. I have 90 degrees left for two angles. So by definition, A and B are complementary because they have to add up to 90. Otherwise, it's not a triangle. So what type of triangle is DGK? Well, take a look. DGK has got one right angle. So that means it's going to be a right triangle. Sorry, I'm just trying to give myself a little more room. So DGK is a right triangle. DGK is this one. GKF is this one. What kind of triangle is it? Well, this is 65. These two are going to be acute. Those two angles are going to be acute, angle KGF and angle KFG. So that's going to be an acute triangle. Angle DGK, or find the measure of DGK. So I got to find the measure of this angle right here. Knowing that this one's 90, this one's 40, well, 180 minus 90 is 90, minus 40 is 50. All right, that's using that concept we just talked about. In a right triangle, these two angles, these two non-right angles, have got to be complementary. So EKF, well, now we got to do a little problem solving here. EKF is this angle right here. Let me change colors. It is this angle right here. So now here's where you got to think a little bit. This whole thing is a line, right? So if this one's 40, this one's 65, whatever this angle is has got to add up to 180. So 40 plus 65 plus whatever that angle is, angle EKF, is 180. So angle EKF is going to be equal to 180 minus 105. So it's going to be equal to 75 degrees. So find the measure of KGF. KGF. Okay, so we know that this one's 75. KGF. So here's where you got to kind of think a little bit. And here's where you're going to have to kind of follow me here. So KGF is this angle right here. That's what we're trying to figure out. Here's what you got to remember. These two are going to be parallel lines. All right, so these two are going to be parallel lines. So if I draw this, that's my transversal. So now here's where you got to kind of visualize this. This whole angle and this whole angle would be consecutive interior angles. Let me say that again. This big angle here and this angle here are consecutive interior angles. That means they add up to 180. So that means this one together and this angle add up to 180. So this is going to be 140. So that makes this one 40. Now that, yeah, you have to visualize that. That one's a tough one. So now if I know that one's 40, how big is KFG? Well, this is 65, this is 40. How big does that one have to be? Well, what's 180 minus 105? All right, 40 and 65 are 105. So that's going to be 75 degrees. So this is starting to put together everything we've talked about. Okay, so this one's 85, this one's 40. Triangles have to add up to 180. So you got 180 minus 85, and that's going to be 95 minus 40 is going to be 55. So angle 1 is going to be 55. So now angle 2 is going to be vertical to angle 1. I know it doesn't look like it, but just go with it. It is. So that one's going to be 55 as well. So angle 3 then has got to be 180 minus these two? Well, we know angle 2 is 55, so I got to take 180 minus 110, so it's going to be 70 degrees. So far, recap the big issues here. 1, every triangle's got to add up to 180. 2, in a right triangle, the non-right angle, those two angles are going to be complementary. So here's kind of the exterior angle theorem. All right, and here's what it says. It says, and it should kind of make sense at some point, it says that this angle, this exterior angle, see, all I did was kind of extend this line going out past the edge. This angle, angle 1, is going to be equal to angle A plus angle B. So angle A plus angle B is going to be equal to angle 1. All right, so we also know that angle C and angle 1 have to add up to 180. So think about this for a second. Think about this for a second. On some level, I hope it makes sense. So angle A, angle B, and angle C have to add up to 180 because it's a triangle. Angle C and angle 1 have to add up to 180 because they're a linear pair. Well, shouldn't it make sense that if I have angle A plus angle B plus the measure of angle C has to add up to 180, then I also have angle 1 plus the measure of angle C has to add up to 180 by the fact that they're a linear pair. Well, what's in common here? Well, C is in common. These two have got to be equal to each other. All right, let me slide this up and take a look here. So 50x, 2x minus 15. So all I have to do is set these equal to each other. X plus 50 equals 2x minus 15. So subtract x, add 15, add 15. So I get x equaling 65. No, not degrees, just 65. So the measure of SNB, this angle right here, is going to be 130 minus 15. There is your answer. Okay, by sides. Jump into by sides. We talked a little bit about this so far. Start over here on the right-hand side. No sides congruent. We call that scalene. Scalene. That is going to be no sides congruent. Middle one, all sides are congruent. We call that equilateral. Which again, it's just a fun word to say. So it's going to be 3 congruent sides. This last one has got 2 congruent sides. And that is going to be isosceles. 2 congruent sides. Also, short idea, kind of sidebar, matching with angles. If I've got an isosceles triangle where 2 sides are congruent like this, that also means these 2 angles are congruent. All right, just kind of a thing to remember. If I've got an isosceles triangle, 2 sides are congruent, the base 2 angles are congruent. So, take a look. So if M is the midpoint of JL, what type of triangle is JKL? So M is the midpoint of JL. So this is 0.75, this is 0.75. So what kind of triangle is JKL? So what kind of triangle is this big one? So this is 0.75, 0.75, that's 1.5. 3 lengths are different, so that's going to be scalene. So what type of triangle is JMK? JMK, this one, is going to be 2 sides are congruent, so that's going to be isosceles. So ABC is isosceles with AB congruent to AC. Find X, AB, and AC if AB equals 3X minus 4 and AC equals 4X minus 9. I realize I went through that very, very quickly. Triangle ABC is isosceles. AB is congruent to AC. AB, 3x minus 4. AC, 4x minus 9. So figure out x, figure out the two side lengths. So 3x minus 4 equals 4x minus 9. Subtract 3x, add 9, x equals 5. All right, so if x equals 5, AB is going to be 3 times 5 minus 4, and AC is going to be 4 times 5 minus 9. Both cases should give me 11 because they should be congruent to each other. So find the value of D if KL is the base of the isosceles triangle. So this is the base of the isosceles triangle. So if I flipped it over, these two would be congruent to each other. So you say 12 minus D equals 4D minus 13. So if I move some things around, 5D equals 25. So D is going to equal 5. They're isosceles, they're congruent to each other. I set them equal to each other. That's very nice. So the value of KL is going to be a whole whopping 11. That's not what they want. They just wanted D. So classify X, Y, Z by the triangles. X, Y, Z is the big one. So X, Y, Z, 50 and 40 add up to what? Yeah, 90. So that's going to be a right triangle. Right. So find the value of X. Well, this is a exterior angle, two alternate interior angles. So I'm going to say these two together, first interior angle, second interior angle, has to add up to 100. That's going to be 11. So, little algebra. Which you guys should be getting excellent at, by the way. Should get you 21. All right. I'll have you guys do that one in class. This is a good one. We'll do this the last one, then I'm done. So, hang in with me. MNP is isosceles. MN is congruent to NP. So if I go MNP, MN congruent to NP. MN is 2 less than 5 times x. So that's going to be 5x minus 2. NP is 7 more than 2 times x. So that's going to be 2x plus 7. PM is 2 more than 3 times x. So those two are equal to each other. So that's where I start. So I'm going to get subtract 2x, add 2, add 2. Hopefully your algebra is coming back to you and you're getting strong with it. So x equals 3, and that's my answer. All right. Get working on your assignment. I really appreciate the work you guys have done through the first 2 units. Keep it up, and we'll do fine. But I would review these concepts a couple times. There's a lot of pieces in there. 1, all the angles in a triangle have to add up to 180. 2, the exterior angle is equal to the opposite 2 interior angles. Isosceles triangles, equilateral triangles, scalene triangles, acute right and obtuse triangles. And yeah, that's a lot of stuff. So make sure you keep all that stuff straight. And that's all I got.